Good morning. Today we are working on CO58. It's going to be a little bit different than what we've been doing. We're still working with those X's and Y's, but we're pausing from that slope-intercept form. Little bit. You're going to see how, well, actually, nope, we're still going to use y equals mx plus b, but just in a different way than what we've been doing. Okay. So CO58 is I can determine if the relationship between two variables shows a direct variation. So some lines have what is called a direct variation. Below are some examples of equations of lines with direct variation and some without. So look at our direct variation examples and look at our not direct variation examples. Do you notice anything? Look at the direct variations, look at the not direct variations. What do we notice is different? Grayson? Plus B. Direct variations are plus 0. They don't have a plus B. Not direct variations have that plus B. Okay. So we're going to figure out, we're going to get some definitions of our new vocab words, and then we're going to be able to figure out if there is a direct variation in the lines or not direct. So, vocab words. Direct variation is a proportional, we've worked with proportions, so it's a proportional or direct relationship from y to x. So we know if it's proportionate, it's going to be a straight line. If it's not proportionate, it's not a straight line. So direct variation or not direct variation. The constant of variation, this is how we find it. We take the y and we divide it by the x. You could set that up as that fraction, y over x. Okay, so it can be a fraction. So sometimes we divide it down to be a decimal, sometimes it's just that fraction. I like to leave it as a fraction. What do we know about y over x? What's another word for that? Victoria? Say it louder. I've got the fan. Rise over run. What is rise over run? The slope. So y divided by x, that constant of variation is the slope of the line. If it is that straight line, that constant of variation is the same for any 2 points on that line. That slope stays the same, right? It's not curved, it's a straight line. That slope is always the same. So the direct variation with a function table, direct variation exists when y divided by x is the same. We know there is a direct variation when it is all the same. So to determine if each function table shows a direct variation, what do you think we're going to have to do? Any guesses? How would we determine if there's a direct variation? Look at our definitions. What do you think, Grayson? Divide what? How do I divide it? Look carefully. Now this matters. How do I divide it? Y divided by X. Super important. Every year I have friends that go 2 divided by 4. That's X divided by Y. We don't want that. We want Y divided by X. It's the slope. The Y has to be on the top. So we would say 4 divided by 2. What is 4 over 2? Clara? 2. Then we have 16 divided by 8. What is 16 divided by 8, Holland? Then we have 20 divided by 10. What is 20 divided by 10? Elliot? And we have 24 divided by 12. What is 24 divided by 12? Bo? 2. Is there a direct variation on this function table? Yes or no? Thumbs up? Yes. Thumbs down? No. Is there a direct variation? I see lots of thumbs up. Every single one of these y over x equals 2. So what would our constant of variation be? Joe? Say it. I have a fan right above me. You got to say it really loud. So would I say, do I have to say 2 over 1? What would I just call it? 2. So my constant of variation equals 2. That constant of variation is also called our what? Slope. So can I put it into the slope-intercept form? I can. So if we have a constant of variation, we need to write it in the slope-intercept form. What would my slope-intercept form be for this one? Henry?
Y equals 2x plus 2.
What do we know about our direct variations? There is no v, it's 0. So when it's a direct variation, it's just y equals the slope times the x. Y equals mx. There's no plus v because there's going to be a 0. So if there's a direct variation, it's just y equals mx. Make sense? Let's try one more together. Let's do this one, the middle one. How am I going to set that up? Bo?
6 divided by 8.
Yeah, I need that y divided by the x. What is that simplified down to, Bo?
3 equals.
What's my next one? Holly? 18 divided by 24, what does that simplify down to? What's my next one? Clara?
30 divided by 4.
What does that simplify down to? And what's my next one? Laura? What does that simplify down to, Laura? What does it divide down to, Laura? What do you say it loud? I can't hear you with the fan right above me. Does it divide down to 3/4, Laura? What am I dividing out of the 8 to get a 3? Don't look at your calculator. Look at the fraction. 8/12. What can I divide out of the 8 that I can also divide out of the 12? What? So if I divide a 4 out, what's my numerator? You got to say it really loud for me. 2. What's my denominator? Do I have a direct variation here? Why not? Oh my goodness, that final one doesn't fit. We can't just assume, oh, 3/4, 3/4, 3/4, 3/4, 3/4, they're all gonna be 3/4. You can't assume it. You have to check every single one because one of them might be off. We don't want to accidentally call this a direct variation. If they don't all look the same, you say no direct variation. Does that make sense? Be careful, you have to do the math for every single one. They all have to match, it's proportional. They all have to be this exact same. If it's not, there's no direct variation. Show me a thumbs up if that makes sense. Any questions on it? Let's look at the bottom part. On the bottom, it says complete each table given a direct variation exists. So they do all have to be proportionate. You're going to fill in numbers that would make it proportionate. Then you're going to write the slope-intercept form. So if I have 3:1, 3/1 is what I'm given, what would be another XY that would be proportionate? Holland. So if I have 6/2, where am I going to fill in the 6 and the 2 on my function table? The 6 is the Y, the 2 is the X. It's super important that you put them in the right place. Okay, Holland is right. 6/2 is going to simplify down to 3/1. I can't put 3:1 because that's already on there. I have to do the 6 to the 2, and I have to make sure that the 6 is the Y, the 2 is the X, because I want 3/1, not 1/3. What's another ordered pair that would be proportionate, Elliot? X is 3, Y is 9, so that would be 9/3. That simplifies down to 3/1. What would be another one, Leo? So which is the X and which is the Y? So if I have 12/4, which is the X and which is the Y? The Y is 12, the X is 4. That simplifies down to 3/1. So they are all proportionate. Is that the only ones I would take? No. As long as it simplifies down to the Y/X is 3/1, any of those numbers would work. Yes?
Kind of a weird question, but if you have a function table,
Yep.
do they have to be in order from least to largest?
No, absolutely not. In an organized brain, you just fill it in that way because it makes sense when our brain organizes it that way. But function tables can be a hot mess. Okay. On this one, as long as your Y over your X is 3/1, I don't care if you put, you got the 1 to the 3, and then you got 24 to, would that be 72? And then you have 3 to 9. You can make it however you want, as long as Y over X ends up to be 3/1. Okay? Am I done? Why not? I figured it all out. I filled in my table. Bo?
Write the line equation in slope-intercept form.
I can't forget to now turn it into the slope-intercept form. What would the slope-intercept form be for this? Joe?
Y equals 1/3 X.
So you said Y equals 1/3 X. Thumbs up or thumbs down, do we agree with that?
Oh,
Do you want to fix it?
Y equals 3/1.
We need to put that constant of variation, 3/1. Do I have to put the 1 on it? No. if you put 3/1 times x, I would still accept it. Proper math, it would look like y equals 3x. Does that make sense? So for the other function tables, you need to make sure they're proportionate. Doesn't matter which numbers you use, as long as they are proportionate, you have the same constant of variation, same slope, all the way down. Then don't forget to do your review. Okay? Any questions on how we're doing this page? So when we come in from lunch, it is quiet work time. Recess will be over. We are gonna work quietly, making sure to get math packets turned in. Those are due today. Then you're making sure your Khan Academy is done. That's due on Thursday. You can be memorizing your gifts of the Holy Spirit. That is coming up soon. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.